here we have no training wheels, right? You need to figure out all these things on your own so you know what you're looking for, right? So let's get a little picture going. So I've got a child flying a kite. So here's the kite. And the kite flies at a height of 300 completely horizontally. It's a perfect world in mathematics. So here we go. So this is a fixed amount because the kite is flying completely horizontal, no friction, wind waves, or wind currents, anything like that. Okay, it's moving at 25 feet per second. So that means this length, and I'm going to label it K, that length K is growing at 25 feet per second. All right, what else do we have here? How fast must she let out the string? Oh, the string is connected to the kite here, right? So I'm going to call that S. So I think we're going to be trying to find ds over dt. Oh, when I see the word when, right? When 500 feet of string has been left out. So when S is 500, do not put it in the picture because you can't use it until after you do the derivative. So now I'm looking for my equation. I need an equation that has the letter S and K and that fixed number. I think you see it, right? Pythagorean theorem, S squared is equal to K squared plus 300 squared. Now I'm ready to take the derivative. 2s ds over dt, 2k dk over dt. And remember, 300 squared is a number. So the derivative of a number is 0. I'm going to get rid of the 2's. So let's see what I've got. S. Oh, I know what S is. That's 500. ds over dt, that's what I'm trying to find. So it's okay for that to be there. K. I don't know K right now, but I do know that dk over dt is 25. So this is where I go back to the original. I plug in the when information into the original equation. You can do it by picture or just by putting it into the equation. So if I was to find K and 300 and that's 500, I could put it into here, right? Or I can think about putting it into here so that I would get 500 squared is equal to K squared plus 300 squared. And it turns out that K squared is 400 squared. So K is 400. So I put that in. So I get 500 divided, oops, went the wrong way. We're trying to solve for dk to d. Okay, I'm sorry, ds over dt. So to solve for ds over dt, I would get k, which is 400, times 25 over 500, and that's ds over dt. Again, it should make sense. This is positive. This length S is growing as the kite moves out that way. All right, let's talk about the boat. So we've got a dinghy, which is just a small boat, being pulled in toward a dock. So we've got a bunch of water on the ground here, or water under the boat here, and I've got a rope that's pulling the boat in, right? And it's on a pulley up at the top of the dock. And what do they tell us here? They said the bow of the boat through the ring is going through the ring on the top of the boat, the top of the dock, that's 5 feet above. So they're trying to say that that's 5 feet. So the pulley is 5 feet above the bow of the boat. That's a fixed number. So let's see what they're giving us. The rope is hauled in at this rate. Okay, I'm going to give this the letter R. dr over dt, let's think about it. I think it's negative. I know it's negative because that length R is getting smaller as the rope is being pulled in. What are they asking me to find? How fast is the bow of the boat approaching the dock? So we're asked to find dB over dt. And then what's the when information? When 10 feet of rope. So again, when R equals 10, don't put that in picture and then don't use it yet. Oops, and I forgot to put the B is right here, right? Find dB over dt. Let's do it. Okay, so I've got r squared is equal to 5 squared plus b squared. I take the derivative, dr over dt. Derivative of 5 squared is 0. db over dt. Let's cancel those 2's. Oops, I miswrote that, didn't I? Get there. So to take the derivative of r squared, it's 2r times dr over dt. Then I can cancel the r's, right? Cancel the r. So now let's plug information in. I'm trying to find dB over dt, so that's totally fine to have that there. So I've got this b carrying along, and I'll find that in a second. And then I've got the dr over dt is -1/2, and the r is 10. So now our mission is to go find b. So I plug the r equals 10 in. I'm just going to draw the picture again. And so I'm going to solve for b. So b will be the square root of 10 squared, which is 100, minus 5 squared, which is 25. So that gives us root 75. So here, this side here, b equals root 75. So then I would get this here gives me a -5 divided by a root 75 is dB over dt. Does it make sense that it's negative? It does, because that length of b is getting smaller as the boat approaches the dock.